Beyond four forces, a new physics awakens. The implications of this cosmic discrepancy ripple all the way down to the quantum scale. The standard model of particle physics, which governs everything from quarks to photons, is already incomplete. It does not account for gravity, dark matter, dark energy, neutrino mass, matter-antimatter imbalance. Now, the cracks are widening. Many physicists suspect a fifth fundamental force, an unknown interaction affecting cosmic expansion or structure formation. Such a force might evolve over time, interact with dark matter or dark energy, influence expansion differently across spacetime, affect measurements of the Hubble constant. What was once theoretical is now the only viable explanation left on the table. A new era of cosmology begins. For the first time in a century, we may be on the brink of a new cosmological model. It's a humbling, exhilarating, and terrifying prospect. The known universe, its beginning, its laws, and perhaps even its future, is not what we thought. And that's a good thing. Because science progresses not by confirming what we already know, but by breaking what we thought was true. The Hubble Space Telescope showed us the universe. The James Webb Space Telescope is showing us how little we understood. The future. Will we rewrite the universe? This is just the beginning. JWST has opened a window not only into the past, but into a new frontier of physics. With every image, every spectral reading, every redshift measurement, it chips away at our assumptions. The next questions are urgent. Is the Big Bang still a viable model? Are there multiple kinds of dark energy? Does time behave differently at cosmic scales? What if the universe never had a beginning? It's no longer about refining theories. It's about letting go of the old ones and embracing a scientific revolution. Is our physics broken? How Hubble and Webb are challenging the foundations of the universe. Every great scientific truth goes through three stages. First, people say it conflicts with the Bible. Next, they say it had been discovered before. Lastly, they say they always believed it. Louis Agassiz, A Silent Revolution in Space. For decades, we viewed the universe through a lens of certainty. From the elegant equations of Einstein's general relativity to the brilliant concept of an expanding universe proposed by Edwin Hubble in 1929, our modern cosmology has stood on pillars we believed were unshakable. But now, ironically, those very foundations are beginning to crumble under the weight of new evidence. What started as a quiet whisper among cosmologists has become a chorus of urgent questioning. The telescopes we designed to confirm our theories are instead revealing anomalies so persistent and profound that we may be forced to rewrite the story of the cosmos. And it all began with the telescope that bears Hubble's name. The legacy of Edwin Hubble, the first great cosmological shift. In the 1920s, Edwin Hubble revolutionized our understanding of the universe by showing that our Milky Way galaxy was not the entirety of the cosmos, but just one of billions. By observing the redshift of light from distant galaxies, he discovered that they were moving away from us, implying that the universe itself is expanding. This formed the basis of what is now known as Hubble's law, which states that the velocity of a galaxy's recession is proportional to its distance from Earth. This discovery paved the way for the Big Bang theory, most famously developed by Belgian physicist Georges Lemaitre. It became the cornerstone of modern cosmology. But what if Hubble's discovery wasn't the final word? When the Hubble Space Telescope called Hubble himself into question. Launched in 1990, the Hubble Space Telescope, HST, was one of humanity's greatest scientific achievements. Orbiting above Earth's atmosphere, it gave us unprecedented clarity of the cosmos, capturing the birth of stars, the dance of galaxies, and the eerie glow of nebulae. But among its many achievements, Hubble made a series of observations that began to undermine the very expansion model Edwin Hubble helped to build. By observing Cepheid variable stars and Type Ia supernovae, celestial standard candles, whose intrinsic brightness is known, Hubble was able to more precisely measure distances to galaxies. The results were shocking. The expansion rate of a universe, calculated using these local markers, didn't match the value derived from the cosmic microwave background, CMB. the afterglow of the Big Bang observed by satellites like Planck. This difference became known as the Hubble tension. The Hubble tension, a crack in the cosmic wall. The Hubble tension refers to the persistent and growing discrepancy between two ways of measuring the expansion of the universe. Local universe measurements, Hubble Space Telescope, supernovae, Cepheids, suggest an expansion rate of around 73 to 74 km/s/mpc. Early universe measurements, Planck satellite, cosmic microwave background, suggest a significantly lower rate, around 67 to 68 km/s/mpc. The discrepancy is now far beyond the margin of error. It's no longer just a data anomaly. It's a fundamental contradiction, and the implications are massive. If these two measurements are both accurate, then something is wrong with the assumptions underlying our models. Is the standard model of cosmology collapsing? The lambda cold dark matter model, lambda CDM, has long been the dominant cosmological framework. It includes lambda dark energy, driving the accelerated expansion of the universe. CDM, cold dark matter, an invisible substance making up most of the universe's mass. 6 parameters that describe the shape, composition, and history of the cosmos. But the Hubble tension has exposed a fatal flaw. Lambda CDM doesn't reconcile observations across cosmic time. If the universe isn't expanding uniformly, or if the behavior of dark energy isn't constant, then the whole model begins to fall apart. And that's exactly what newer telescopes are beginning to suggest. James Webb Telescope, the catalyst for a second cosmological revolution. Launched in December 2021 and fully operational by mid-2022, the James Webb Space Telescope, JWST, promised to peer deeper into the universe than ever before. It was designed to observe infrared light, the oldest, most redshifted light, allowing it to see the earliest galaxies and stars. What it revealed was not a primordial, chaotic universe slowly forming galaxies, but a cosmos already teeming with massive, structured galaxies only 200 to 300 million years after the Big Bang. Among the early shockers, GLASS Z13 and CRS 93316, fully formed galaxies that exist just 300 million years after the Big Bang. Macy's Galaxy, another ancient galaxy that shouldn't exist that early. Supermassive black holes. JWST discovered black holes a billion solar masses large far earlier than expected. These discoveries don't just conflict with lambda CDM, they obliterate it. The implications: a universe without a Big Bang? The standard model predicts that large-scale structure formation, galaxies, black holes, and massive clusters, should take billions of years. But JWST shows them appearing almost immediately after the universe began. This suggests one of two possibilities. The Big Bang didn't happen the way we think, or perhaps not at all. Our understanding of time, space, gravity, and matter is fundamentally flawed. Theories now being discussed in cosmological circles include a dynamic or evolving dark energy, a fifth fundamental force, modified gravity, e.g. MOND, emergent gravity, exotic particle fields or interactions, a cyclic or bouncing universe instead of a singular Big Bang, a history of ignored warnings. Hubble saw it first. Perhaps we should have seen this coming. In 2011, Hubble detected a galaxy with a redshift of Z equals 10.3, placing it around 480 million years after the Big Bang. At the time, many dismissed the finding as an outlier or a fluke. But JWST has now revealed dozens of similar and older galaxies, some with Z values exceeding 13, possibly as high as 20, which would place them just 150 to 200 million years post-Big Bang. Even the discovery of the star Earendel in 2022, a single star dating back 900 million years, has been eclipsed by Webb's revelations that entire galactic populations existed well before. The warning signs were there. The old model is dying.